Hi class, these notes are going to be on law of sines, and law of sines is a formula that we will use to solve a non-right triangle. Another term for that is an oblique triangle. And I like to show you the proof of the formula so you buy into it so you can see where it comes from. You will never be expected to do this on an exam or anything, but it's a quick proof, so stick with me. I'm going to go ahead and give myself an oblique triangle, so no 90-degree angles. Well, that was brutal. Let's go try that again. If you go quick, somehow they look straighter. And I'm going to label that vertex A, B, C. And what I'm going to do is I'm going to drop an altitude from B. So in other words, I'm creating two right triangles. So really I have three triangles. I have the big triangle, I have the shaded triangle, and then the non-shaded right triangle. And now what I'm going to do is I'm going to name this guy my H because it is your height of your triangle. Now, my drawing doesn't do it justice, but we have no idea if it's cutting it in half, that base, so we're not going to assume it, and it actually doesn't. So we know, since we talked in class, that across from big A, our angle A is our side A, across from big C is our side C, and across from big B is little b. And now, I'm going to go ahead and stand at angle C. And I'm just going to focus on that red shaded right triangle. And if I find sine of C, well, remember that's opposite over hypotenuse. Well, now let's take a walk and stand at angle A. Well, if I find sine of A, that's going to be opposite over hypotenuse. And again, because I'm just focusing on that non-shaded right triangle. Well, we can see here that both these equations have H. So what I'm going to do is I'm going to isolate H. So H equals A times sine of C. And over here, H equals C times sine of A. Well, remember back in the day, that good old transitive property. If these two things equal H, then they have to equal each other. And because I know what the formula is, I'm going to keep going with it so it looks like the formula. So now I'm going to divide both sides by A. And I end up getting sine of C equals C times sine of A over A. And now I'm going to divide by A. So, divide by C, I meant to say. Another way to show that, I'm just going to use a different color so it stands out, is I can multiply by 1 over C. That's the same thing as dividing by C. So now I have sine of C over little c equals sine of A over little a, because these would reduce out. Well, there's part of the formula. The full formula for law of sine says sine of A over A equals sine of B over little b equals sine of C over little c. We just did not get this middle piece. Oops, I didn't mean to do that. We did not get the middle piece because we dropped the altitude down from B. So if we wanted to get this one, we would just create a new orientation and draw the altitude from a different vertex. So, A or C. But it's going to be the same process, so I'm only going to just show those two. All right, here is the formula. You will be given this formula. You're going to have it memorized by the first two problems you do, but I do give the formula to you. And we're going to talk about now when to use law of sines. And then we'll get into some examples. So law of sines, you can use it when you have something known as ASA. And what that is angle, side, angle. Or when you're given side, angle, angle. The second case is also if you have two sides in an angle. Now, you are not going to memorize this. I want you to use your brain for better things in your life. But this is important, excuse me. This is important to recognize because when you're given this case, problems start to arise. So you need to be able to look at what's given to you and realize, oh wait, that's a side angle versus a side angle side. So let's make sense of this. So when I say angle, side, angle, I mean some angles given to you, the included side is given to you, and another angle is given to you. So the main thing is, for this to be true, the side has to be between the two angles. Now for the next one, it doesn't matter which side, okay? Let's just say this side's given to you. Well, then they're saying side, angle, angle, this angle, and this angle. So now the difference is the side is not included. All right, the last one is side, side, angle is given to you. Now you can see they clearly are writing this to be appropriate and professional, but you can write it the other way, all right? Now, you're not going to memorize this because the rule of thumb is you're going to use law of sines if you can get a full ratio. So what that means is if you are given angle A and side A, we're going to use it. If we're given angle B and side B, yep, or C and side C. If you can't get a full ratio, you're going to be stuck because we don't know what it equals. And that will come into play in your next section. But right now, luckily, we're in the law of sines section, so this is all we're going to be using. But in class, we're going to put them all together, so we have to know when to use which. Okay, I'm going to stop the video here, and then we'll get into examples.